Hello guys and welcome to this channel. My name is Roman Narvaez. I am an structural engineering sending this workshop from the city of Gothenburg here in Sweden. Alright, today we are going to go through finite element analysis for structural engineering. I opened the application Fusion 360. We get the workspace here and we are going to model. The first thing here to model is a profile. We are going to choose the following profile. We are not exactly at the beginning what profile, but maybe 160 or 180. So the first thing that we need to choose is a plane. Create a sketch and choose a plane. So we choose the plane XY, and you need at the beginning to create some construction lines. You choose construction lines and a reference from this point to the other side of the board here. And in the x-axis, a similar procedure. Good. At the beginning, we choose randomly a web for this. Need to change to common lines. So we choose a randomly web here. For example, this one. It doesn't matter the thickness of the web in this stage. And for the flange, of course, another. It could be in that one. Right. We are going to use some kind of constraints because this is a parametric software. So we're going to develop parametric objects. So the constraint, it would be a symmetry. We need symmetry for this web. And you see the constraint here. We need a constraint, symmetry constraint for the flange as well. And we have that. All right, at this point we need to mirror at the bottom of this web, the flange, the upper flange. So we choose the four faces or lines of this flange, and we mirror respect to the mirror line, and we get on the other side at the bottom the other flange. Now what we need is to constrain in some way the dimensions of the different elements. In this case, for example, the thickness. Put someone like 10 millimeters. The width of the flange, maybe 210 for example, and of course the thickness of the web, we can put 8 millimeters. So we will add that this sketch we are going to extrude the behavior will be only one body. In that case, we need to arrange only one body here. So the constraint over there on the upper side of this sketch, and on the other side the same procedure. So, and the other. Good. So there are different, we have 3 elements here, so we want only 1 element. We choose trim there, and trim on the other side. Perfect. So we have now our HEI bin. And what we want is, for example, HEI, for example, 180, which means 180 the width and the height 171. So we go inside here, 180. So we need to put a dimension here as well, a constraint for the dimension. $179. I think it was that number. No, 171. 71. So, and the web, what thickness we have? The web, the thickness of the web is D here, and it would be 6, and the flash knife 5. Here is okay, 6, not 5, 9.5. So now we finish the sketch. Beautiful. We get the isometric view again, and we see our sketch here. Now we need to extrude. I'm going to extrude 1000 millimeters. Look at that. This is what we call 3D modeling. So this is our bin. I'm going to copy the sketch here. This is the sketch. To make we have the column, and we have the beneath the bin as well. So we copy this sketch. Control copy. We close this. We get to the isometric view, and we create another sketch. We need to choose the face as well. So, and we have on the clipboard, and now Control V. Correct. We move this to the side, and we click OK. Finish the sketch. We look at that. We have the other. We have the bin here. We are going to extrude this to a new body, and we extrude 1000 millimeters. And here is the bin. So we mark this, and we are going to move. And we say point to point. This point here, we want to move this, and the touch point, it will be on the upper side of this column. So now we have our system, one column and one bin. So that is the first step to calculate the design. The software has another modules, another workspaces, and there are the simulation, for example. When we get into the simulation space, and we choose a static stress, we create a study for this. The first thing we need to consider here is, for example, the materials that we are using. We check a look about the materials. Of course, the properties. We're going to use this kind of steel. I'm happy with that. And we need to put some kind of constraints in this system. The system is a cantilever. So in finite element theory, we need to know what we are going to use. For example, we are going to use the differential equation of a beam, this whole stuff of mathematics for the deformation, the rotation, the moment, shear and force. This is the equation that we are going to solve for a cantilever. We have in finite element modeling and solution, we have the exact solution and we have the approximative solution, the FEM solution. So we are going to use Fusion 360 to get the FEM solution of this. FEM use a lot of matrix algebra, and actually this is the equation of motion here, but we don't have any motion, like for example acceleration or gravitation, for example, though we are going to then to solve with inertia force, and this is the application. Later on, when we get the results, we're going to check the stresses with the von Mises theory about the stresses energy, and check control our results here as well. For example, the von Mises for the web. Okay, but that's about the little concepts. Then we need to put the loads here. Constraint first, of course. And then we are going to fix this bottom place of this so, and we fix it. We look at, we have a pad here, pad block. That's the first time think about that. What happened with the beam? The beam has a problem here. It's not in contact, actually in contact with the column, because if we make a check here, we see that missing structural laws, and another message here about automatic contacts, manual contact. The contact between column and beam is not quite enough right now, so we choose automatic contacts. The software is going to generate these contacts between these two construction elements. Right. Now we have these contacts, and we are going to put the loads. We say that we put a load in this corner as well, and we're going to put 5,000 newtons. So we see that a pre-check is already green, which means that we can begin to make the calculation. So we choose solve, and we get into the solution. We are going to call FEM1 calculation. FEM calculation number 1, for example. So we wait a little moment for this calculation. Of course, we can review things like safety factor. We're going to review the von Mises stress analysis, and we are going to view the deformation and the strain as well. With that, we will see if there are stresses that are bigger than the allowed. Maybe we need to make some changes for the system structure. Right, so maybe we can look about about some theory here. So we are going to look at the normal stresses. They are correlated to the von Mises. We're going to look about the stresses here. The more theory here is used for example, the shears capacity and things like that. I'm going to try to make briefly these calculations here. So we will see that how long time. Maybe we need 2 minutes more, the 34% of these calculations, the 50% and almost already. We will see how much is this. All right, close. The safety factor is 1.38, which means quite enough good. We will see that where we put the lows, there is a bending here, so maybe we can improve that with a plate, but we are quite enough sure. We look at, for example, the web here. There are a lot of stresses, but we can check von Mises. Here is von Mises. As we see here in this web, the moment is trying to bend this flange, and the stresses are concentrating this point here. But if you see here, the concentration is 167 max, and the steel we have here is 345 megapascal, which means that we have very good marginal steel now. Okay, we can check the deformation as well for this finite element structural analysis. The displacement is 2.68, so maybe we need to put a plate here. We can make, but it will take a little more time. And the strain here, we have a strain very little as well, so we can look at of a simulation here. And for example, I took this one. I make a simulation for this strain. Okay, the simulation 10 minutes, 2 ways. Right. So I don't know why it's not working this. Yes, now it's working. Right. That's the strain. We can call the meshing here. That's very quite okay as well. We take for the von Mises, for example, simulation here. Right. So, and finally we can take, for example, a simulation for the deformation as well. And it's very good, this calculation. Very nice. So we take the displacements, deformations. That's the way that the cantilever deforms. So that's a basic design. You can find another kind of, for example, I have here, I can show you in a moment. I have another type of elements. For example, we can take this plane change here. You can take the simulation here. Look at that. We take, for example, the stresses here, and the simulation of the stresses. This is a thicker plate which is welded to the main plate. You see the weld here where the stress is. You have at the top level of the corners the stress on the welds, and of course on the screws as well. Okay guys, I hope that you enjoy this presentation. I hope that you find interesting this. I will get more examples later. So give me a thumb and see you around. Have a good time. See you again.